All right, in this function, I actually want to think about changing the input in maybe a different way than we've seen in this function. I said it again in this video. So let's say we define a new function, g of x, as being the f function, where we subtract 2 of x minus 2. So whenever we're writing these functions in terms of the other, what we're kind of saying is I want to be able to use the f machine to find g. And we can see here that what we are changing is the input. So let's say we happen to have known, because we've done it before, that when we plug 3 into the f function, we get out 7. So if I plugged in 3, boop, 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 do whatever it gets done, it gives me out 7. So in order to have, so what this is saying is different inputs, same output. So in order to get out 7 from the g function, sorry, if I want to get out 7 here from the g function, I get that out when I plug 3 into the f function. So I actually have to plug 5 into the g function. So g of 5 equals f of 5 minus 2. So now I plug 5 minus 2 into the f function, and it gives me out 7. So g of 5 is what equals 7. So let's consider this a little bit. So if we had a graph, or just coordinates, on the f function, we would have the point 3, 7. On the g function, we would have the point 5, 7. Because we're going to be subtracting 2 from the input, we actually have to be 2 units bigger in x in order to get the same output. Which means that if we're comparing these 2 points, the g function actually shifts 2 units right. I have to start with a larger value when I work on the g function, 2 units larger, so that if I plug it into the f function, I get out the same answer.